In this video, I want to show how to work with arithmetic sequences to turn it into an arithmetic series to find the sum. So our first example, we have the sum 1, 2, 3, a series of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to find the sum. To find the sum. So to do that, what we're going to do is just add the first term plus the last term plus the second term plus 9 plus 3 plus 8 plus 4 plus 7 plus 5 plus 6. If we add vertically, 1 plus 10 is 11, 2 plus 9 is 11, 3 plus 8 is also 11, 4 plus 7 is 11, and 5 plus 6 gives me 11. So altogether, that the sum would be 55. Let's talk about in more general terms. Suppose we don't know the number of terms and we're dealing with 1, 2, 3, etc., all the way to n. So we can rewrite this as 1 plus 2 plus 3 plus etc. plus n minus 1. What we're going to do is we'll write in the sequence, the sum notation, which we use Sn for sum. That means sum. So we're going to write it as 1 plus 2 plus 3 plus ... plus n. And then we'll write it as, that should be n minus 1, not n. Then we'll have Sn equals n plus n minus 1 plus n minus 2, etc. plus 1. So this first term, we add 1 plus n, that gives you 1, n plus 1. And we have two Sn's. 2 Sn's, S of n. And then 2 plus n minus 1 will be just, again, n plus 1, because 2 minus 1 is 2. 3 plus n minus 2, again, will be n plus 1 plus n plus 1. So there's n of these guys. So we'll divide it by 2. So my formula becomes n times n plus 1 all over 2. So that's a general idea of our formula. So let's just try that for the previous example. So the previous example, we had 10 terms. So it was 10 times 10 plus 1 all over 2, which would be 10 times 11 all over 2, which gives me 110 divided by 2, which gives me 55, and our formula works. In our next example, we're given this symbol here. This means sum. That's the Greek symbol sigma, which means sum. This is my sigma notation, which means sum. So first thing you want to do is find the first 5 terms of the sequence. So to do that, all I have to do is plug in 1, 2, 3, 4, 5. So we'll say A1, which is just 2 parentheses 1 plus 50, which equals 52. You plug in A2, 2 parentheses 2 plus 50, which gives me 54. You plug in 3, just 2 times 3 plus 50, which gives me 56. You plug in 4, 2 times 4 plus 50 equals 58. One more time. 5 will be just 2 times 10 plus 50, which gives me 60. And here's my first 5 terms. It'll be just 52 plus 54 plus 56 plus 58 plus 60. And we're done. Now, it says find the value of S of 50. That's what this problem's all about. So first thing we want to figure out is the formula that we're going to use. So in general, to find the sum of a sequence, we have the formula S of n equals n times a1 plus an, all that divided by 2. So we know our first term already. That's going to be 52. And we know there's 550 terms. Plus, we need to figure out a of 550. So to do that, what we're going to do is just plug in 550 into our problem, into the equation. So we're going to say a 550 equals 2 times 550 plus 50. Two times 550 plus 50 gives me 1,150. So this becomes the same thing as saying 550 times 52 plus 1150, all that divided by 2. Put this in the calculator. Times 52, you might want to use parentheses. I'll add some parentheses. 1150, and then divided by 2, and we get the sum to be 330,550. And we're done. In our next example, we're given the sequence -50 plus -44 plus -33 plus et cetera, plus 2038 plus 2044. And we want to find the sum of the sequence. The problem is we don't know how many terms there are, but we do know the first and last term. So again, what we're going to use is we're going to use our a sub n, which we know is 2044. We know that our first term is negative 50 plus our common difference. We can see that we're adding 6. So we plus 6 and minus 1. So we're going to find out how many terms there are. That will be my n. So we're going to do negative 50 plus 6n minus 6. That would be negative 56 plus 6n. So we're going to add a 56 to the 2044. So that would be 2100. Equals 6n. Now just divide by 6. And we get n equals 350. So we know there's 350 terms. Now we're just going to apply our formula to find the sum of the sequence. So our formula would be S of 350 equals 350 times negative 50 plus 2044, all that over 2. Plug in the calculator and we get our sum. So 350 times negative 50 plus 2044 divide by 2 and we get 348,950 and we're done. The last example I want to do is a word problem. So here's our situation. In training for a marathon, an athlete runs 7,500 meters on the first day, 8,000 meters on the next day, 8,500 meters on the third day, and so on, each day running 500 meters more than the previous day. What's the total distance the athlete will run over 30 days? So first we need to figure out how many meters he ran on the 30th day. So to do that, we're going to say a 30 equals 7,500, which is my first term, plus we're increasing by 500, and then 30 minus 1. Plug that in our calculator, and we can figure out how many meters he ran on the 30th day. And that just gives me 22,000 meters. Okay, now we're going to find the sum of the 30 days. So that would be 30 times 7,500 plus 22,000, all that divided by 2. You plug in the calculator and we get the sum of our series. 100. And we get 442,500 meters, and we are done. Hopefully that will help you complete your work for the week. Be sure to email me if you have any questions.